Hello, this is Sir CJ and welcome back to Physics 9. This is the 14th session in this series and it's a new book. Welcome to a new book. This is about the conservation of momentum. It's divided into the following parts. The first part is a pre-assessment, multiple choices shine. It's about conservation of momentum. The second part is under observe. It's a problem-solving topic under problems on impulse and momentum. And then the last one is an activity 68 under observe, entitled spare change. The learning competencies that we have for this session are the following. So, infer that the total momentum before and after collision is equal. Actually, yung pagko-conserve ng momentum before and after, yun actually yung main topic natin. Kung ano ba ang nangyayari sa momentum ng mga bagay bago at pagkatapos nilang magbanggaan. Ayan. And then the second learning competency naman is for you to be capable of examining effects at saka mag-predict ng mga causes of collision-related damages o kaya mga collision-related na mga injuries that are usually related to the road. Ayan, sa biyahe. Okay. Now, let's begin with the pre-assessment. Prepare a 1/4 sheet of paper and answer the following questions. So for the first one, there are different ways in which forces can interact with each other, and among them is through action interactions. So it's related to the third law of motion you studied when you were still in grade 8. Which among the following options shows an action interaction force? So is it A, rockets that are launched in the air? B, air that is escaping from a balloon? C, a basketball ball that is thrown at a wall, then bounced? Or is it D, all of the above? Now, if you need more time, you may pause this video. But once you're through, let's proceed with the next question. Question number 2, in a game of billiard, the white cue ball hits the 9 ball with a superb precision. Now, which among the following is the same before and after the collision? A, is it the momentum of A or the white cue ball? Is it B, the momentum of B or the momentum of the 9 ball? Is it C, the total momentum of the system that is combining the white cue ball and the 9 balls momentum? Or is it D, the difference in momentum? Number 3. On the road, different things can happen. One day, there was an accident that involved an 8-wheeler truck loaded with soft drink colliding with a Toyota Corolla down a bridge from where Vernie lives. You can assume that the severity of the damage between the two vehicles, but when it comes to comparing the momentums of two bodies that have different sizes and masses and velocities, which among the following statements is correct? So is it A, less massive bodies have less momentum if it has the same velocity as an equally massive body? B, the body with a higher velocity will have less momentum if it has the same mass as the other body? C, more massive bodies have less momentum if it has greater velocity than less massive bodies? Or is it D, more massive bodies will have less momentum if they have the same velocity as less massive bodies? Alright, number 4. Before the announcement of the lockdowns in Angeles City, Jared loves playing with his skateboard behind Marky Mall. It was his way of releasing his stress from the heavy amount of tasks he needs to finish in school. He went there with his friend, Ralph. His bag was quite heavy, so while riding his skateboard, he threw it to Ralph, who was ready to catch it. If he threw his heavy bag towards the right, towards what direction will Jared's resulting motion be? Is it A, forward, B, backward, C, to the right, or is it D, to the left? Number 5. Moving objects have momentums, and when they collide, the energy they have must be conserved. In which of the following types of collision is momentum conserved in such a way that when two bodies collide, they will suffer deformations and move with only one velocity? Is it A, elastic, B, inelastic, C, perfectly elastic, or is it D, perfectly inelastic? Remember, this is just a pre-assessment, so our task talaga dito is to know kung gaano na ba karami yung alam nating information about this new book. Let us now proceed. Number 1, the answer is all of the above. So yes, all of these scenarios are going to include action-interaction forces. Number 2, it's the total momentum before and after the collision. Number 3, less massive bodies will have less momentum if it has the same velocity as an equally massive body. Ayan. Number 4, to the left. And number 5, it's perfectly inelastic. Now, it is fine if you got a really low score in the pre-assessment. What matters is you will get a higher score later sa summative assessment, okay? All right. Now count the number of correct answers you have and write your score over 5. Now we're done with the pre-assessment on multiple choices conservation of momentum. Let us now proceed with the following problems. So for problem number 1, companies of automobiles often subject their car models to collision tests to know if the car is passively safe for passengers. Cars are subjected to hit a cement wall for this purpose. Suppose that a 1,100 kilogram car is sent running towards a cement wall with a velocity of 15 meters per second, which resulted to an impact force of 185,000 newtons, which stopped the car in its tracks. How long did it take for the cement wall to stop the moving car? The following givens are indicated. Now, I want you to first do yours. Okay, so yung munang sayo. Write the givens that you see. Now, once you're through, check out the following. Mass is 1,100 kilograms. That's the mass of the car. The velocity of the car was 15 meters per second. The force that was applied towards the car by the cement wall was 185,000 newtons. Now, the unknown factor is, since it says how long did it take, it's obviously time. Alright, for our solution, we'll be recalling the formulae na diniscuss natin dun sa previous book. And we will be using Ft is equal to mv since meron tayong force, unknown and time, may mass, and velocity. So it's quite simple. The next one, we'll be substituting the givens. It will be 185,000 newtons times time. That's equal to 1,100 kilograms multiplied by 15 meters per second. And then we'll proceed with the operations. So 185,000 newtons in time couldn't be actually solved. So we just let them stay like that. Whereas for 1,100 kilograms multiplied by 15 meters per second, we get 16,500 kilograms meters per second. And then, since it's obvious that the next step should be including the equality of the two sides of the equation, we'll be doing just that. And in this case, we'll be dividing both sides with 185,000 newtons to cancel it out on one side and then divide it on the other one. So it's obvious that we'll be getting a really small value. And in this case, time is equal to 0.09 seconds. That's how quick it's going to stop the car. For problem number 2, Uncle Jason just bought a new 1,500 kilogram Ford pickup type car and he was so excited to drive it. At one point, he sped up from 30 meters per second to 65 meters per second in only 8 seconds, and he was thrilled at the efficiency of his new wheels. At that exact point, how much force acted on the car? So look at the following problem and then identify the givens you see. And then check them against the following. The mass of the car was 1,500 kilograms. And then the initial velocity of the car was 30 meters per second. And then its final velocity was 65 meters per second. And then the time it took for that to happen was 8 seconds. Now, the question is how much force acted on the car. So, what are we gonna use? Since meron ng initial and final velocity, I think we cannot use the previous formula. So, we'll be using a new one. Okay, so yung Ft is equal to mv dyan. Remember na the new one that we're talking about is we will be using two of them. So, paano siya? mvi, yun yung isa. Tapos isa naman is mvf. Okay. At this point, I hope that you can still recall that formula. Can you? So, yung v dyan, hindi lang siya basta isang velocity, okay? So, in this problem kasi, meron tayong dalawang velocities. So, remember that in one of our formulae, meron tayong ft is equal to mvf minus mvi. Do you remember that? Okay, now look at the substitution of the givens. Do you see it? Okay, so yung mvf is right here. So, mass, tas final velocity. Minus, mass, same lang siya, initial velocity. The time is over there. Okay, hindi na siya lipat dito. But it will be transferred later on. We proceed with the operations and we'll get 8 seconds F. So, force is just right there. Is equal to 52,500 kilograms meters per second. So, obviously, we're gonna be dividing both sides, this time by 8. To cancel it out on one side, tas matitira na lang yung F. Okay, so 52,500 kilograms meters per second is going to be 6,562.5 kilograms meters per second squared, which is equivalent to Newton. And that is the amount of force applied to the car. Okay, remember that when you divide kilograms meters per second by second, in this case, it's going to just be cross multiplied. So kilograms meters per second siya. So mangyayari is magi-square lang siya. So kilograms meters per second squared. Okay? All right. Now we're done with the second part. Those are two sample problems. I hope that you got them correctly because medyo marami na rin naman na tayong mga ginawang problems so far, no? In this series. So, the next part is an activity number 68. It's called spare change. These are our objectives. So, first, you have to be capable of explaining how an object's momentum is conserved in a collision, and then appreciate the real-world applications of the conservation of momentum and the collision of bodies. The materials you'll be needing are the following. So you'll need a sheet of paper, pencil, and 10 pieces of coins. Now, if you have those materials already, let's begin. Step number 1, align yung mga 9 pieces muna of identical coins on a smooth surface. Align mo sila just like the way it's being shown right now. Number 2, with the last coin, yung pang 10, ayan, hit them on one side. The first coin in the line. Something's gonna happen, and what you have to do is you have to note your observation on your sheet of paper. Next one, get 2 coins. Okay, so that's like including the first one a while ago, and hit the row with those 2 coins. Now, something's gonna happen, something that's quite different. Note your observation. Alright. Now, for the first guide question, in grade 8, which among the laws of motion proposed by Sir Isaac Newton was observed in this activity? So just recall, when you were still in grade 8, we discussed 3 laws of motion, right? Which among those laws of motion do you think is being observed in this activity? Explain this connection comprehensively and preferably with details. If you need more time, you can pause this video. But if you're through, let's proceed with the next question. Question number 2, when you hit the row of coins with one coin, does that one coin have a momentum before it hit the row of coins? So answer that with a yes or no. Now, what do you think happened to that momentum? Kung meron siyang momentum, what happened to that momentum when it hit the row of coins? If you need more time, pause this video. If you're through, let's proceed. Number 3, is there any difference when you hit the row of coins with 2 coins from when you hit the coins with just 1 coin? May pinagkaiba ba? Now, if there is a change, kung mayroong pinagkaiba, there's a difference, what are they? Kung wala naman, in what way are the 2 instances quite similar? If you need more time, pause this video. But if you're done, let us proceed. Question number 4. The coins in the row do not have, initially, a momentum because they were just at rest. Bakit ganon? Kasi momentum is equal to mass times velocity. So if the velocity is 0 because it's at rest, multiply that by the mass. Kung kahit gaano pa kabigat yan, yung bagay na yan, when it's multiplied by 0, it will always be 0. So the momentum will be 0. Now, what happened to the coins when their row was hit? No, yung mga coins na walang momentum, what happened to them? Now, which coin showed an evidence of the transfer of momentum? If you need more time, pause this video. If you're done, let's proceed. Okay, so for question number 1, the correct answer is it's the third law of motion. It's also known as the law of interaction. And it states that for every action, there is an equal and opposite reaction. Now, observe ito dun sa activity since the number of coins that hit the line almost always resulted to the number of coins pushed away on the other end. Halimbawa, when you pushed one coin towards the row, only one coin on the other end was, natanggal. Pero when you properly do it, you push 2 coins towards the row, that will surely push 2 coins on the other end. Ayan. Question number 2, the correct answer is yes. The coin has a momentum. Yeah, yung pinush natin. Now, that coin has momentum before hitting the row of coins. Tapos yung momentum niya napasa dun sa mga coins until na-reach niya yung isang coin from dun sa may bandang other end. Okay, so the momentum was nandun dun sa coin na pinush mo at napasa lang yun dun sa first, second, third hanggang dun sa 9th coin on the row na obviously nag-show ng evidence of a transfer of momentum. Now, for question number 3, yes, merong pinagkaiba yun. More coins got pushed away on the other end because of an increase in the momentum, that is an increased mass of the coins that were pushed towards the row. That is if you did this properly, okay, if you did this correctly. Question number 4, when the row was hit, the first coin received the momentum. I explained this a while ago, coming from the coin or the coins that were hitting them. And that momentum was quickly transferred to the next coin in the row until it reached the last coin in the line that showed the evidence of transfer of momentum. So, yung mga coins na nasa pagitan ng first coin at saka nung coin na pinush natin towards that row, hindi sila nakapag-show ng evidence of momentum kasi they immediately transferred that momentum to the next one until ma-reach yung pinaka-end na coin at wala na siyang kumbagang pagpapasahan immediately. At ang nangyari lang, natanggal lang siya dun sa linya. Ayan. So that is it for the last part of this session, Activity 68, Spare Change. We are about to embark on a really long discussion about the conservation of momentum. Pero I hope that while we are doing these discussions, you are already parang knocking on the engineer within you, because these are things that those people, mga mechanical engineers, feeling ko rin mga civil engineers siguro, no? Or even actually mga forensic scientists, when they're, or ano, mga investigators or detectives. These are the kinds of things that might have been parang kumbaga visiting their minds every once in a while in their professions. And if you feel like this is your jam, okay, welcome to the conservation of momentum. This is Sir CJ, and I hope that I will be seeing you in the next video lesson.